So on part 3 of your project, it asks you to find the trajectory from home to your final destination. And you can find your distance on that website, MapCrow. You can also find your latitude and longitude. So I'm going to use my example. We'll say moving from, this is part 3, trajectory. So moving from Fresno, which is in the middle of the state, to Hawthorne, so you're going to take on this path, southern part of the state. You have a trajectory that looks something like this. And we'll complete our triangle, showing your horizontal, then your vertical coming down. And we know that the distance between these 2 points on MapCrow is about 211.2 miles. So the big idea here is we want to find our other 2 measurements, our components, our x and our y. But the problem is we can't find that until we find our angle here, which we can call theta. So we'll call this angle theta. So to do this, we want to use our latitude and our longitude. We know that Fresno, we'll call this Fresno, and then our final destination, Hawthorne. We know that Hawthorne has a latitude of, actually it's a point, negative 118.4 and then 33.9, and Fresno is negative 119.8 comma 36.7. Okay. Now those are acting as almost coordinates on our coordinate plane. So what we're going to do is we're going to draw a second triangle. We're going to call this a similar triangle, just with side lengths that are a bit smaller. So we'll still call this Fresno. So same thing. Okay. Now we want to find the difference between those points. So I'm going to take the difference between 119. We'll do 119 minus 10.8 minus 118.4, and we get 1.4. So the distance, our horizontal distance, is 1.4, and our vertical distance would be 36.7 minus 33.9, which gives us 2.8. That's this distance, 2.8. And these are going to be similar triangles. Okay, so what we're going to do is we're going to use this triangle on the right, the small guy, to find our theta angle here. Okay, we'll call this theta. So the only ratio we can use here is tangent, because we have opposite and adjacent, so tangent of theta is equal to, and we're going down, so we're going to call it negative 2.8 over 1.4. And to solve for this, we're going to take inverse tangent of each side. Inverse tangent. Okay. This cancels. And we end up getting theta is equal to negative 63.4 degrees. Great. So now we know that this angle here, theta, is equal to 63.4. And you can see that it's going backwards, traveling backwards, 63.4. So we'll call this 63.4 because these are the same triangles. I'm actually going to write it over here so we can see. So this is 63.4 degrees. So I know that that angle here is 63.4 degrees. And if I know that angle, since these are, I should say these are similar triangles. Similar triangles meaning they have the same shape but not the same size. So if I know that angle is 63.4, I can now calculate my other sides. So I'm going to use sine of theta, and we'll call this my y coordinate and this my x. So sine of theta and my theta is equal to 63.4 is equal to my opposite over my hypotenuse, 211.2. You end up solving this and you get y equals 188.8. And then you do the same thing with cosine. Cosine of 63.4 is equal to x over 211.2. So this angle, it would be x, or this side would be 94.6. So this distance here, x, is equal to 94.6, and my y is negative 188.8. So now you have your components, and so our component form for this, which these are going to be your special numbers because you want all of your x components to equal the x and all the y components to equal the y. Component form is 94.6 and negative 188.8. This will act as your answer, so you want all the x's to equal this guy and all the y's to equal this one. And also you found out your angle here is 63.4. Let me highlight it. Well, that's great, but we want to make sure we have that in bearing notation. So my bearing for that component form, so the bearing would be 90 degrees, because that's your first quadrant coming around to here, plus 63.4, which will equal 153.4 degrees is the bearing. Okay. I hope this gets you started. I know there's a lot here to digest. You're going to need to start with your magnitude, which is this guy, and then from there use similar triangles and the latitude and longitude to figure out the difference, and then eventually figure out your angle. And once you figure out your angle, you can work backwards to figure out the component form. Alright, hope this helps.